In-space manufacturing on a large scale is a capability that has seemed like science fiction, but is now moving closer to reality. Rendezvous Robotics, which came out of stealth mode last month, is one startup that's working on the challenge of how to build the future in space. In this episode, I'm joined by co-founder Dr. Ariel Ekblaw to hear more about the autonomous modular tiles that Rendezvous Robotics is developing to dock and build structures in space, and what this could mean for structures like phased array antennas, solar panels, or in-space manufacturing sites. Ariel is also the founder of the Aurelia Institute, which works to democratize space access through education and outreach. We talk about her passion for building the future of human life in space, which she gave a TED Talk on earlier this year, and how she envisions a future in space where humans don't just survive, but thrive. I'm Rachel Jewett, and you're listening to On Orbit, the podcast that asks, what's our future in space? Hi, Ariel. Welcome to the On Orbit podcast.
Hi, Rachel. Great to be here. Thanks so much for having me.
Yeah, thanks for joining. So last month you had some really exciting news with Rendezvous Robotics coming out of stealth mode. And I know that the company is focused on building the future of in-space infrastructure and also ties in with some of the work that you've done with your nonprofit, the Aurelia Institute. So I'd love to hear, just to start us off, can you talk to me about Rendezvous Robotics and kind of the approach that the company is taking with in-space manufacturing?
Sure. It's a really big couple of months for us. This is work that I started as my MIT PhD, kind of at the intersection of aerospace structures and architecture, to focus on exactly like you said, in-space construction, in-space manufacturing. How do you actually scale the building blocks themselves? We sometimes think of them kind of as space Legos that would enable us to do much larger physical installations in orbit than what you can fit inside of a rocket payload fairing. And I think the really special thing about Rendezvous is they're moving beyond this era where we used to do things that were, primarily origami based, like James Webb, something that's really big that has to be exquisitely carefully folded up. Mm-hmm. There's a lot of different single points of failure that get introduced in a process like that. Mm-hmm. And instead, if we can rely on autonomous robotic units like the tesserae units, in this case, that leverage electromagnetism to be able to help them do that docking, a lot like how your, mag charger might come in and kind of self-dock, that I think is a really revolutionary new capability. And in particular, the way that they are focusing on kind of implementing that is thinking about applications like large solar panel arrays, radiators, maybe phased array antennas, like that kind of really big infrastructure.
Mm-hmm. Yeah, that's super interesting. And I get what you're saying about, James Webb, that there are, like you said, so many single points of failure, so many things. And luckily, all of that worked and was an amazing feat of engineering. But the idea of just doing things in a different way is really interesting. So what are some of and that is one of the problems, but so what are some of the things to overcome with moving, like what are the limiting factors of how things are unfurling in space and how a new way of in-space manufacturing could change that?
Yeah, absolutely. So one of the big challenges is just how do you construct something bigger than your biggest gantry? So on Earth, if you think about when we build skyscrapers, we have really big cranes. We have tooling that itself is very large. And how do you begin to build things in space without having to have a gantry or a crane, or without having to have a robotic arm, for example, that's going to do a lot of that construction? It means you either need to be self-unfurling, like origami, or you need to be self-assembling, like our system. And I think that our system builds on some interesting precursors from biology, kind of at the Brownian motion scale, how things are energetically able to be favorable to come together, to dock, in the case of, proteins or DNA, to self-assemble at small scales. And in a microgravity environment, when you're in free fall, around an orbiting body, you have this kind of amazing environment where self-assembly works again, like it does in
Mhm.
biology at a really small scale, but in this case, in space at a macro scale. And you can leverage this free fall to let the tiles, in our case, our tesserae tiles, kind of autonomously float and dock together. We've tested this now inside of the International Space Station twice in miniature, and the tiles do this kind of incredible dance, like this pirouetting, where the
Mhm.
polarity of the magnets helps them turn towards each other as they're floating towards each other to self-dock and take on the, in this case, the geometry that we're targeting at the time. And we're super excited. We're working towards our next International Space Station mission, which is going to be hopefully in the first half of next year. So we won a big NASA grant to be able to test again inside the ISS. And then, of course, also working towards a longer term test regimen for work outside of the space station as well.
Okay. Yeah, and I want to hear a little bit more about the background of the tesserae tiles. So, I understand that you worked on that at MIT. Can you talk to me a little bit about where the idea came from and just some of the history of how those have been developed?
Yeah, exactly. So it started out as MIT as my PhD work. We originally did it on a series of different zero gravity flights, so a lot of testing on parabolic aircraft. Then had the opportunity to test inside of the New Shepard Blue Origin rocket for one of the
Mm-hmm.
reusable rocket launches, actually really early on in the history of New Shepard. It was a big honor to get to be part of that mission. Then we transitioned to International Space Station testing, did a launch with nanoracks on CRS 20. I believe that was in 2020. So it was like February, right before the pandemic.
Oh,
And
wow.
then the next mission was with Axiom on Ax-1, which was their really historic, fully private mission to the International Space Station. And so we've kind of had this interesting transition as our work has evolved over the last decade of getting to be part of these vanguard launch and testing opportunities, which is a testament to how quickly the space industry is changing, right? The cost to get to space has dropped from, what is it, like 50,000, 65,000. There's a bunch of different numbers, but in the tens of thousands of
Hmm.
kilograms, or sorry, tens of thousands of dollars per kilogram in the shuttle era to now, what, like about 1,500 a kilogram, maybe 2,000 a kilogram, and soon with Starship expected to be around $200 a kilogram or lower. That makes it like FedEx. If you can ship cargo around the world, you can just about ship it to space, which is really empowering for this next wave of companies. And it's why we think Rendezvous Robotics has such a really compelling moment. It's such a good inflection point to begin thinking of scalable infrastructure, science fiction worthy scalable infrastructure, because now the cost to get that mass to orbit is low enough. The next problem that we're really trying to solve, the next bottleneck, is real estate. Just being able to build big enough and scalable installations in orbit.
Hmm. Yeah, you've been one of like the early stage customers of this like future space economy of testing technologies in orbit and customers on these like suborbital flights testing in microgravity. Like that's just very cool to see. You've been one of the customers, and now you're moving to that next stage. So I want to talk about the step to now becoming a company and raising your seed round. So, how did you come together with your co-founders, Phil Frank, who's been with Nokia and AT&T, and Joe Landon from Lockheed Martin, and kind of how did you decide it's time to take this from, moving outside of a research project to becoming a commercial company?
Right. So I basically looked around in my network and found the two people that I admire the most. We really, really carefully handpicked Joe and Phil. So Joe, I have known almost 8 years now. He was actually a mentor of mine in the space industry when he was working at Lockheed
Mhm.
for their advanced, concepts division. Did some really amazing work with Crescent. I'd even known him
Wow.
in his planetary resources time and when he was doing some early space investing. I think he just brings an incredible, like inside of the industry space experience to this company. And he's also got a really big vision for where this company can go and the work that we can do, the different type of customers that we can support in the industry right away. That's the other kind of delineating factor is that the habitat work and this focus that I have had and that's my passion area for the future of human life in space, that's something that the Institute will continue to work on in collaboration and partnership with Rendezvous. And Joe, I think, is really well placed to take this company forward for their beachhead market, which is the focus on autonomous construction of really large infrastructure like radiators, solar arrays, phased array antennas, this kind of non-human crude work. And then eventually really excited to, get a chance to merge the two. And then Phil brings this incredible scale of deal making from his experience at Nokia. So billion-dollar experience in M&A, really, really thoughtful business leader, amazing for the culture of building a young company from day one to be able to scale dramatically to be what we hope will become the backbone of the space industry. So Phil was really engaged in kind of the backbone of telecom in the early days with 5G
Yeah.
and AT&T and Nokia. And I think we're at a similar moment where we need a leader like that in the space industry to say, okay, groups like SpaceX, they have built the road to space. Now, what are we going to do with it? What's the infrastructure backbone for all of these different services that are going to grow out? And I think Phil and Joe together as a team are just really exceptional in the skill and the expertise that they bring together to be able to take Rendezvous forward.
Yeah, and I thought it was a really interesting combination of people with different backgrounds. And I was like, oh, what an interesting team that you guys have put together. So I think that's really cool.
Thank you.
All right. So then now that you've raised the seed round, what are the next steps? What are you guys, maybe like the next 6 months? What are some of your goals in the next 6 months?
So we're doing a lot of technology road mapping and planning development work, getting our offices set up in Colorado, getting ready for this big demo that's going to be the first example of at-scale test array tiles that will assemble outside of the International Space Station. And to do all of that, we're really building an exceptional, talent pipeline and team. So if folks are listening to this podcast, we're actively recruiting, actively hiring, thinking about the intersection of avionics, hardware design, structures, controls, all of these different really kind of fascinating subsystems that need to come together to execute the test array vision. So super excited to be building out this technical team as we work over the next 6 months towards these technology demonstration missions.
Yeah. So you said that you have a demo on the ISS coming up next year, and
Mhm.
then you would be looking to demonstrate, like not inside the ISS, like out in space.
Yeah, exactly. Yeah, that'll be so we're inside, we have an interior ISS demonstration of our prototypes again in 2026. And then after that, we're going to be heading outside of the space station and doing a bigger scale autonomous test.
Very cool. What kinds of like are are there interesting types of communications needed for the pieces to communicate with each other when you say autonomously coming together? Like, are there comms needs in that?
I'm sorry, say that again. Comms
Like
needs?
communications, yeah. It's like, would the tiles be like communicating with each other in terms of like, I don't know, will they be to the
Absolutely.
satellites, or I'm just curious about what's needed there.
Yeah, so there's several different dimensions of comms for how we're integrating into the hardware. One is the tiles themselves communicate wirelessly. So on a small scale, we've been leveraging Bluetooth. At a big scale, there's all kinds of different RF protocols that you can use to have them talk and kind of negotiate their status. So the test array tile system is modeled on swarm robotics. So the tiles have a local state knowledge of what they're sensing and interacting with, and it's how they can autonomously interact with a neighbor, determine if that is a good bond, and whether to keep that bond or pulse off and try again for a different configuration. So there's a lot of local knowledge that's housed within the tiles. And then they also have global system knowledge through a mesh-like network that enables us to do more sophisticated planning, path planning, guidance, nav, and control between the system as a whole. And so that communication of the local state knowledge to the global system is definitely using comms and avionics that are on board. And then, of course, there's the connection to the ground. So, traditional spacecraft systems, you always have to go through the processing, being able to get your electromagnetic spectrum bands, making sure that you have that connectivity to be able to get data down and live commanding and ops between your ground station and what's up in orbit.
Yeah, so a lot of different layers there. So what kinds of structures do you see Rendezvous Robotics building in the future? Like what types of things would this type of manufacturing enable in space?
Ah, so, one of our favorite applications that we're thinking about right now are really large aperture or antenna sizes, being able to do the type of formation flight that can be required for phased array antennas. There's also a lot of interest right now in space-based solar power. How do you self-assemble tens of thousands, hundreds of thousands of units to make these really big, gathering infrastructure for all the photon energy coming in for space-based solar power? So that is, I think, a huge opportunity area. Radiators, so heat rejection, being able to just produce a lot of surface area for heat rejection. Not only is it important for space habitats, but also going to be really important for this coming age of AI data centers, where if we really are going to move a lot of compute out into space, there's kind of a common misunderstanding that, oh, it must be easy to cool this compute infrastructure because space is
Mhm.
cold. But it's actually the opposite, right? There's no convection in the vacuum because there's no air mass that's moving around to take the heat and move it away from your electronics. So you have to do radiative heat transfer, which typically means a lot of surface area, basically, to get rid of and reject that heat. So super excited to be exploring kind of that next generation of if we are going to do AI data center infrastructure in space, how do we build that? How do you self-assemble the infrastructure required for those servers, and then also the heat rejection infrastructure around that. And then, of course, my favorite answer, which is my long-term passion, really inspired by science fiction, is how do we build the space stations that will ensconce us as a spacefaring species? Like, how
Mhm.
do you begin to build things that are bigger than your biggest rocket payload fairing so that the modules of your individual rooms are much more spacious? Right now, what we're focused on and super excited about is this notion of an orbital biolab. So,
Mm.
using the tesserae tiles to self assemble a really large sphere, a buckyball, so like a sphere approximation. That's because for a given amount of surface area, a sphere is the maximum interior volume. And what we want to do inside of this orbital biolab, which we would do in partnership with another space station company, and probably in partnership with a big anchor biotech partner, is
Mm.
say, okay, so we want to make sure that by the time the International Space Station is decommissioned, that we have a really viable open science laboratory on orbit. The big space station companies right now, a lot of them have proposals to be able to do biology in orbit, but they're going to have to be driven towards proprietary models where people pay for access for that. And then typically those results also stay private. But what was so special about NASA and ISS National Lab and CASIS is the open science aspect of what was happening on the station. So we want to be able to replicate that when the ISS is decommissioned. But even better, what the ISS couldn't do because its volume was so constrained is high throughput manufacturing. So we want to actually be able to scale up the number of artificial retinas that could be, uniquely manufactured in microgravity, but instead of just making, tens or low dozens of them, how do you make hundreds of thousands of them to really cure macular degeneration on the surface, right? So you make these little
Mhm.
artificial retinas, companies like Lambda Vision really leading this amazing work, but how do we get them enough volume to scale up their manufacturing in orbit? And I think there's a lot of advantages. There's amazing companies like Varda who are starting to look at this
Yeah.
strategy through uncrewed modules, but there are also a lot of advantages towards maintaining a crewed habitat version of this kind of infrastructure. So super excited to be using the tesserae tiles towards that future vision as well.
Absolutely. So you think that you mentioned that Rendezvous could potentially collaborate with one of the space station companies to enable something like a large scale lab in orbit.
Yes, exactly. Yeah, I think we're able to potentially leverage tesserae for not just flat, large surface area items, but also potentially for really, yeah, larger scale enclosed volumes.
Hmm. Yeah. What has the last month been like for you after coming out of stealth mode, and like what type of response have you heard from the space industry and interest from people in working with Rendezvous and um, maybe like potential like what types of collaborations or future customers the company could have?
Mhm. We've been super thrilled with the response. I mean, really grateful to the payload team, to Space News, to TechCrunch for just some fantastic coverage of the company when we came out of stealth in September. The big thing for us, right, is we just want the best possible talent in the space industry to come and build this company with us towards a really expansive vision towards what life in space and, autonomous infrastructure in space can look like. And so I think we've been really excited and grateful for that exposure, and the reception has been fantastic. Like we're oversubscribed for the roles that we're trying to hire for now. And we're continuing to grow, and we'll do more hiring throughout the year. In terms of partnerships, I mean, really excited to be in early conversations with some key partners who have the customers for things like space-based solar power or AI data centers, thinking about these next generation big infrastructure dreams that now we know maybe we've wanted to do these things since the 1970s, like space-based solar power, but finally the costs to get to space are dropping enough that these really grand ideas are feasible. So starting to do LOIs and talk to, customers and potential users there. My parents are both ex-military. So my
Okay.
dad was a A-10 fighter pilot. My mom was one of the first women to ever fly for the US Air Force. And so I'm very comfortable with and very pro using Tesserae for the benefit of our country and defense. And I think looking at potential partnerships with the DoD to do really revolutionary capability for dynamic infrastructure protections in orbit is a really, high compelling area. And so we'll also be looking at that ecosystem.
Yeah, interesting. What do you think it could mean for, you had mentioned like large phased arrays. Like I could see like a satellite operator having a business case with that needs a really large array and this type of manufacturing making that possible to assemble in orbit. So, um, do you think it could have implications for satellite operators and manufacturers?
Mhm. Yeah, absolutely. I mean, we're looking at all kinds of different potential hosted model ideas to be able to support the power or comms that different satellite operators might need. Maybe there's a version of Tesserae in the future that is kind of like the common resource bus in a really large installation sense, and can dock with future satellites. So yeah, I think there's a lot of potential overlap, and we would love to be able to be a useful provider to some of the needs of the satellite industry, particularly in that comms bucket that you and I were talking about
Yeah.
before, not just the comms that are needed to keep Tesserae operating, but the ways in which Tesserae could contribute to telecom and comms
Hmm.
and communications is around this idea of phased array antennas and being able to build towards that future.
Yeah. Um, the ISS it has a limited amount of time left in orbit, and there are a lot of companies that are, or not, there are, a number of companies trying to build the next commercial space station, and hopefully there will be like multiple options in the future. But do you think that the space industry will be ready for when the ISS is decommissioned, or like how, I don't know, do you think that we're in a race to get everything ready, to have options in place by the time the ISS is decommissioned?
Mhm. I mean, there's never like a good constraint is what we all need for good design. And I do think that that provides a useful motivational structure right now for the space industry to be able to mature and level up to be able to replace the ISS. I think personally, if the space station companies end up facing delays to being able to replace the ISS, I could anticipate that from a national security standpoint, it's makes more sense to extend the life of the ISS for another year or two than have a gap. And so I don't realistically see the space industry weathering a gap. But there is massive pressure to make sure that we don't have to unnecessarily extend the ISS lifetime again. And I do think it's in the interest of a lot of infrastructure companies, ourselves included, to be able to offer a viable alternative. And so we're working hard with a bunch of different partners that are, in the CLD phase, looking at this next generation of habitable and non-habitable infrastructure for orbit, really trying to push hard on making that timeframe.
Yeah, right. Definitely. I mean, like you said, pressure is it's a good motivator. You've said that you're really passionate about space habitats and living in space, and I wanted to hear a little bit more about, wanted you to talk about a road show that you did, kind of taking a space habitat structure around the country. So, can you tell me about that project and what kind of response you received and kind of what you were hoping to achieve with it?
Yeah, so what you're describing is something that we call the Tesserae Pavilion. This is a full-scale architectural mock-up of what our Tesserae habitat would look like. So um, it's about 25, 30 feet wide, really big geodesic dome. When
Hmm.
you encounter it on Earth, where we have it set up, of course, you're going to have to walk into it. There's gravity, but it's designed so that you would actually be floating in it if it was, in the way that it would be deployed in orbit. And so the experience of walking into this orb is really interesting for people because they actually get to have a visceral visual sense of what it would be like to inhabit the entirety of a volume. So when you're in a room on Earth, we think we live in 3D, but we really kind of interact with that space in a 2D plane. The XY plane of the floor, but we're not hanging out up at the ceiling. Whereas in the Tesserae dome, the entire volume would be inhabited. There's no delineation between ceiling, floor, and wall.
Hmm.
And so we have interesting installations like a zero gravity algae stained glass window where kind of like the cupola on the International Space Station, this is the big window inside of
Hmm.
Tesserae. And the idea is that light can pass through the algae and then produce a little bit of supplemental oxygen for the crew. And the idea behind installations like this inside the dome is to show the public, kind of the next generation of the public who might actually be living and working in space, that there's a version of space architecture that's really exciting. That's not just the interior of a science lab, as impressive as the ISS is. Not everybody wants to live in that particular aesthetic environment. And so the Tesserae Pavilion is a way to communicate to people, yes, it's absolutely got to be functional. Survival comes first. But maybe there's a way to begin designing the architecture of our lived experience in space that is more about thriving than just surviving. So we also have a zero gravity kitchen, have prototyped a lot of different fermentation ideas for how you can have, healthier food that's also good for your gut microbiome and tastier than freeze-dried food. All these different elements of the joy and kind of the things that make day-to-day life worth living. We're now at this amazing juncture where we can begin to design that into future space habitats. So that is the, in between near-term pragmatic and speculative vision that the Tesserae Pavilion shares when we take it on the road. And it was at the Seattle Museum of Flight for about 4 months, end of 2024 into 2025. And then we had an amazing opportunity to take it to TED when I gave my TED Talk this year. And now, for anybody listening, we're actually looking for its next home. So we're super excited to bring the pavilion to another venue this year and next year, and really
Okay.
excited for people that might want to do that with us.
Yeah, that's great. And I was struck from seeing the pictures of it that it is beautiful. And it's not just like a utilitarian design. And I hear that when you're talking about it, that you're talking about thriving and designing things that are making not just being there to be there, but the idea of like bringing beauty into it and making it a place that people can enjoy and thrive. I think that's really interesting.
Thank you. I think it's a huge mission statement of Aurelia Institute, the nonprofit out of which Rendezvous Robotics has spun out, which is to say, how can we democratize access to space? There's kind of three ways of doing this. The first is the bottleneck right now in space isn't rockets anymore, it's real estate. Even if the cost to go to space dropped even more dramatically tomorrow, we only have room for about 14 humans in orbit, period. So that really needs to change. The first step of democratizing access to space is to build infrastructure that's scalable, that can welcome more humans into that future. The second part of democratizing access to space is to say, okay, once we get them there, what makes it possible for a broader swath of humanity to feel at home or to feel comfortable, whether it's space tourism or maybe it's scientists that within a couple years actually are going to start commuting to space themselves to do their own science in orbit. You don't have to be a NASA astronaut anymore to postulate a career in space. And then the third aspect of this is to say, how are we training the workforce, doing the workforce development and the economic mobility to welcome more people from all different walks of life into the space industry? I was very lucky to start my career in physics and then do aerospace engineering at MIT. And that is a background that is typical of people in the industry, is to start really technical. And that's how you get a chance to participate. But we need space lawyers and space ethicists and space artists and space designers and architects. We need kind of all of these different talents on Earth to begin really contributing to our future in space at scale. And so the third piece of this idea of democratizing access to space is really doing the recruiting and the education and the outreach to bring more people from around the country and eventually around the globe as we scale into this really amazing industry. So it's a huge point of pride for us. And then also just like a really big focus area for the mission of the nonprofit Aurelia Institute.
Yeah. Do you think that there's any challenges to be overcome there in letting people know, people, artists, healthcare professionals, teachers, people that are not just working in science and engineering, that space is for them also? Do you think that space has like a messaging issue?
Mhm. I think space is incredibly aspirational and there's so many amazing aspects to the space industry that get people really excited.
Mhm.
It's just that sometimes in the last few decades, it has seemed less like something that everyone gets to participate in. And maybe it's very aspirational, but out of reach. And so that's the messaging aspect that I would change in the space industry, is to show people very concrete ways of getting involved. Like, come apply to Aurelia Institute to come on one of our zero gravity flights. We bring 25 to 50 people every year into zero G in partnership with Zero G Corporation, where we run our zero gravity flights. Like, there are achievable access points now to being able to participate in the space future. And I also think, in the last couple of years in the media, space was depicted as a domain where it's, particularly for high net worth individuals
Mhm.
who are traveling to space for tourism. And I think that the media covered that negatively, but I actually view that as an incredible achievement because that's exactly how commercial air travel started. It was a luxury thing. People would dress up to fly in first class. It was a very special
Mhm.
experience. And then as that became more popular, the cost dropped over time and it became democratized. That's exactly what these companies like SpaceX and Blue Origin and Virgin Galactic and others, that's what they're trying to do. Is yes, it might start in a pattern where it's for high net worth individuals who can go to space, but their companies themselves are trying to succeed in democratizing access to space, which I think is really special. And I think the more that we can get that message out, that people listening to this podcast, if you have kids, your kids will very well have an opportunity to get a job where they commute to space for work. They might not go 9 to 5 every day, but certainly within a week, or maybe it's kind of like an oil rig or going to Antarctica. You go for 3 months and then you come home. That is a really near-term future that people should start preparing for, and that we're really excited to help people prepare for.
So I have to ask, do you have any plans or ideas about when you might go to space?
Mm, I'd be so delighted to get the chance to go. I think in a few years, companies like Axiom, who are doing their private astronaut missions, it's feasible that in addition to the amazing people that choose to pay for those missions to go up, people like John Schaffner, who we've worked with in the past, I think there might be opportunities to have a scientist kind of accompany them and do work with them as a
Uh-huh.
partnership. And so I'm really excited to see where that model evolves. And certainly I would be absolutely delighted if there was an opportunity to go up on a private spaceflight mission or something with a future commercial space station. In the meantime, I've had the immense privilege of getting to do the zero gravity flight like 13 or 14 times now. So I've spent
Mhm.
a lot of time practicing, spent a lot of time in those parabolas of microgravity, like how NASA trains astronauts. And I think it's been a great way to really prepare for this ultimate future where I would love to get a chance to do my own science and experiments in orbit.
Yeah, absolutely. You've got the practice. You're ready to go. Well, Ariel, it's been so great to talk with you today. Is there anything else that you wanted to share about Rendezvous Robotics or the Aurelia Institute that you'd like our listeners to hear?
Sure. I just think we have this really special moment where it feels like ideas that were science fiction through the 50s, 60s, and 70s are becoming a near-term reality. And we're building that vision at Rendezvous. This is the company that will, I think, become the foundation of in-space construction and manufacturing. And we want to do this in partnership with people. So if people are listening and you want to come work for us, apply. There's an amazing team that we're building out in Golden in Colorado.
Mhm.
And I cannot think of a better team to lead it than Phil Frank and Joe Landon. Amazing people to work for and really, yeah, expanding the foundation for the next era of orbital infrastructure. Thanks so
Yeah,
much, Rachel, for giving us a chance to tell the story.
yeah, absolutely. Thank you.